I'm Beckmeyer. My presentation is called My Internship and Career Path. Like Dr. Bancher kind of said, you guys might be sitting there saying, why should we care what you did? But right around the corner, you guys are going to be graduating, getting jobs. A lot of what I did and what I did do was all entry-level work. So if you get a job within the field, this is something that you may well be doing in the future. So the overview for my presentation, I'm going to talk a little bit about my time at St. Francis. I'm going to give a little bit of a background in water treatment. I know there's some underclassmen here that may not have any experience or anything with water treatment, so I'm going to throw that in there. I'm going to talk about my career path, which includes my internships. Future, say some things I hope to get done in the future, and then open up for some questions. So my time at St. Francis. I started school here in 2012. All right, who here's a freshman? Raise your hand. What were you guys doing in 2012? What grade were you guys in? Am I that old? You guys in like 6th grade? All right. All right, so officially I was the class of 2016, but I stayed an extra semester, so I graduated with the class of 2017. In that time, I was able to get a BS in environmental engineering. I got a concentration with ecological engineering, and I ended up with a BA in biology. I had a lot of fun at St. Francis. My time at St. Francis, I was able to, I originally came here to play football. I played football here for 2 years. Ended up that, you know, I'm not going to go to the NFL, and I'd rather focus on my grades. So I quit football, focus up a little bit there, which was much needed. I ended up starting the rugby team here, which I'm happy that is still going. I have some members still here, so thank you guys. I played Phi Kappa Theta, still involved with that indirectly. I majored in biology, so I joined the scuba club. Ended up going to St. Lucia for the trip in the summer, which you guys could do. It's great. You learn a lot about ecology, and ecology and environmental engineering kind of go hand in hand. I was on the homecoming court, which I thought was a great thing, a great experience. After a few head injuries, I was not able to play rugby for any longer, but I still was able to coach, and I'm thankful that I was still able to do that. This is the crew. This was after our senior projects. We gave the. Do you guys still do the presentation over JFK? I think we were the first year that did that. I thought that was really cool. I'm gonna make fun of Andy because we all got the memo. So I'm gonna give a quick disclaimer. I'm from North Jersey. I say water. Like, that was one of the first things that everyone pointed out to me. Is like, you say it funny. Most of this is about water treatment. I'm gonna be saying about 100 times, if not more. Just give me some slack. So this is Glenn Beckmeyer's quick water chemistry background crash course. So limiting reactant. We have the equation A plus B equals C, and B is used up quickest. B is the limiting reactant. So if we had more B, the reaction could still go on. Simple, right? You guys follow me? There we go. I want this to be interactive. I don't want this just to be maybe out here being boring. I hated those. So limiting reactant in an aquatic system. C and P. Can someone tell me what C and P stands for? All right. The C in C and P stands for carbon. The N stands for nitrogen, and the P stands for phosphorus. The growth of biomass in an aquatic system is directly proportionate to C and P. So the more C and P that is introduced, what do you guys think is going to happen to the biomass? The more C and P, what's going to happen to biomass? More biomass. There you go. The higher levels of C and P that are introduced into an aquatic system that causes an overabundance of biomass, what do we call that? Eutrophication. There we go, it was. So this is probably my favorite illustration of the DO sag curve. So you know, when you give presentations, you got to practice it 1, 2, 3, 4, you know, many times. I was doing this for my little Italian grandmother, who up until this point, like we were doing really good. And then when I told her that fish and aquatic organisms breathe oxygen, she was like, "What are you saying? They breathe water." And I said, "You know what? We're just going to stop this here." So this is a DO sac curve with the illustrations on the back of the aquatic organisms. I just really like fish. So here you can see in the clean zone, in the healthy stream, you have high dissolved oxygen, so you have many different levels of organisms and low BOD. When water pollution, like CMP, is introduced, that causes eutrophication, the BOD raises, and because the BOD raises, we have this sag in the oxygen. And then if you look at the illustrations, when this sag in the oxygen occurs, we have these lower levels of organisms that aren't too favorable to humans. I'm a big fisher. I'm a fisherman. I like fishing. I don't like this. I want this. Or I want this. So that's why I think, personally, I like this illustration a lot. Eventually the stream will heal. The BOD will lower, and the oxygen, the dissolved oxygen will raise, and then we have the more favorable kind of fish that you want to go after. All right, this is the nitrogen cycle. I think the nitrogen cycle is huge if you're going to do anything with water treatment. It's like the most basic kind of cycle that has to do with water treatment, and I just think that if you're going to do anything with water treatment, you should more or less have this memorized. One of the things that you should just be able to spit out. Who can tell me what the first form of nitrogen is that is introduced? Okay, we got ammonium. Can someone tell me the next one?
Nitrite.
Maria, I think we talked about this. Come on.
Nitrite.
Nitrite. All right, what's next?
Nitrate.
Nitrate. And then ultimately, what do we want?
N2.
N2. What's special about N2? It's a gas. It will bubble out. It will leave the system. We want that to leave. Originally, in wastewater treatment, the ammonium and the nitrite at high levels, we wanted to get rid of those because they're toxic. I also have a saltwater fish tank at home. If you have high levels of ammonium and nitrite, you're going to kill all your fish. You want those toxic levels to go down before, cycling the tank. You want to cycle your tank before you introduce your fish. Can someone tell me how this process happens and what kind of environment?
Anaerobic.
It's aerobic. So high oxygen, but you're right on path. That was the right kind of thinking. So high oxygen. We need high oxygen to make those processes happen. Can someone tell me what environment this process happens in? This is aerobic, anaerobic, so low oxygen. I'm going to talk about this a little bit later. I have a friend that is a civil engineer. He went to a good civil engineering, and he took a few environmental courses. And when I talked to him about it, these arrows, I asked him, what are those arrows representing? Like, what is actually, like those arrows, like what is that thing that's making those changes? And he said, oxygen is making those changes. You're adding oxygen, and it's changing. Can someone tell me what those those arrows are actually representing? Say louder.
Bacteria.
Yeah. So different types of bacteria are being represented by those arrows. So one type of bacteria is making the first change, another type is making the second change. So I'm going to talk about my first internship. My first internship was in between my sophomore and junior year, which is a good time, I feel like, to get one. Then you have your background information, more or less. You're there. You're able to kind of have some intellectual conversations with people you're working with. Spit some big words, and they're like, "Oh, nice." Then in between my junior and my first senior year, I split that time in between as an engineering intern and as a lab technician. So as an engineering intern, I did inflow infiltration for the sanitary system going to the plant. As a lab tech, I did daily water quality tests. So we were testing like BOD of the aeration tanks, stuff like that. So in the pink, we have Bergen County, New Jersey, just to show you kind of location where it's at. To the right of it is New York City. You know, you can see Pennsylvania to the far left. I get a good idea of where we're talking about. This is it zoomed in. So there is approximately 940,000 people that live in this county. This was taken back in 2015, so we are on a growing rate. That is the highest population in any New Jersey county, and New Jersey is the most densely populated state. So it is just a lot of people living all on top of each other. That's important to us because the amount of people go up, the amount of wastewater goes up. You know, people use the toilets. And the green is exactly where, you know, we would cover. Alpine is kind of its own little world out there, and then to the west goes to Passaic County, which has an even bigger plant than we do. The two dots represents the two wastewater treatment plants that are found within the VCUA. The one on the left has an average flow of 77 million gallons a day, and the one on the right has around 3.5 million gallons a day. I worked at the one that had the 77, much larger plant. This is an overview of the plant. Again, it's Bergen County Utilities Authority. It's a conventional, wastewater treatment plant. It's activated sludge. A few unique things that I think make it stand out to just from other plants. Across the river is a PSE&G power plant, right? So in power plants, they need water for their cool downs. And we would supply them with around 3.5 million gallons a day of clean effluent over to the power plant. So instead of having to pull it from another source, they use our outputs as their inputs, which is good environmental engineering. We also have two cogen engines. They could either be run on natural gas that is piped from the power plant that we give the water to, or they could run on biofuels. It is not totally ready, to my best knowledge, to run on biofuels alone yet, but through our digesters, they collect the biofuels and then we burn it for energy. Again, we're using a waste as an energy source. Another cool thing, so wastewater treatment plants, if you use an activated sludge, produce sludge. So our plant would dewater it, put it on barges. Instead of having to use trucks, many trucks, we would load up the barge maybe once or twice a week and then float it down to Newark, New Jersey. Float it down to the beautiful city of Newark, New Jersey, and they would dispose of it there. So, as an engineering intern, I mostly focus on inflow and infiltration. There's a slight difference, but kind of has the same result. So, the infiltration that we mainly focus on was cracked pipes. So if you have a sanitary line and has a cracked pipe, water from the outside environment is going to get into it and raise the flows in that pipe. The inflow that we focused on was from illegal connections. So there we have illegal roof drain connection and illegal sump pump connections. Does everyone know what a sump pump is? Does someone not know what a sump pump is? All right, so a sump pump is something you put in your basement. If it floods, it's just a pump to get the water out of your basement. But why should we care about any of this? Well, we're found in the Meadowlands. Has everyone heard of the Meadowlands before? If you're a football fan, that's where Meadowlands Stadium is. It's where the Giants and the Jets play. But the Meadowlands is also this very important estuary for the area, and it has a lot of ecological value. This is a great shot. I'm thinking about printing it out and hanging it up in my office. This is the Meadowlands, and then here's the New York City skyline in the background. So infiltration, inflow in the Meadowlands. The Meadowlands is tidally influenced. We're close enough to the Atlantic Ocean, going up to Newark Bay, New York Harbor, that we're tidally influenced. A higher influent flow, either that come from storm or from tidal events. Wastewater treatment plants are only made to handle a certain amount of flow. So if we have inflow of clean water, we're just going to, non-sanitary waters into the system through illegal sump pump connections, and infiltration of clean water into sanitary system through cracked pipes, that's going to raise that flow. And flows that are higher than what the plant was designed for are going to ultimately lead to waste going straight into the environment. So what we did, and I wasn't a part of this decision making, I was the low on the totem pole. We had a community outreach program where we would go to different houses, or we would go to different towns, and we would give them information, like I just said, about, this is what's going on. The average person, they flush the toilet and that's it. Most people don't really know what's, going on behind the scenes. In Bergen County, they actually made a law that if you're going to sell your house, the BCUA has to go to your house and check if you have sump pumps and see if you have illegal connections. It's not so much the homeowners that are doing it, it's more that the contractors that they use just want a quick and easy fix, cheaper, they're making more money on it, in and out, all right, let's get it done. So you might have an illegal connection and not really know anything about sump pumps and not really know about it and the impact that you're causing. This is a roof drain going into a pipe. Who could tell me where that pipe is going? Just from looking at that right there. Because I can't. Is that illegally connected to the sanitary? Is that going to the street? Is that going to, is it leaching out underground? I can't tell. So what we would do is put dye into pipes like that and put a hose in to wash out the dye, and then we would go and open up the sanitary manhole in the middle of the street. And if the dye came into the sanitary manhole, then you know that you have an illegal sanitary connection. So I did that for the whole first summer, and then half of the summer after that, and along with the lab technician work at the BCUA. So in between my first senior year and my second senior year, I worked with Beckmeyer Engineering. If that name sounds familiar, I know a guy there. It's in East Rutherford, New Jersey. Again, that's where Giant Stadium is. I'm going to give you a pinpoint of where that's at. I was an engineering intern. Beckmeyer Engineering is municipal engineers, but we also work with wastewater treatment, we work with stormwater, and we work with contaminated soils. Ooh. Okay, so this was one site that we had worked with, BJ's Wholesale. They called up the town and said, listen, we've had a problem with flooding for all this time, we tried to do something in the past, it's not working, can you guys come back out and see what you're doing? It's hurting our business. And lower business means lower taxes, and the town likes taxes. So the more business they get, the town's happier. There's a drainage ditch that runs along the side of the BJ's, and up in here, that's the parking lot. This is actually a PSE&G solar panel site. So there's the drainage ditch. That's Route 17. Route 17 is a major commuting highway. It runs north-south. It connects New York State down to Bergen County, and then you have connecting highways that go across to Manhattan and the rest of New York City. So if you're coming through Bergen County trying to get to New York City, you're more or less probably taking Route 17 at one point. The Meadowlands Stadium, if the map continued, would be somewhere in that area. We have an Amtrak train rail that runs right over the drainage ditch. This is Berries Creek, which it ultimately flows into. Berries Creek runs into the Hackensack River. Here is a sign that you can find all along Berries Creek telling you not to eat the crabs and striped bass that you could catch in this river. The entire Berries Creek is a Superfund site. Do we know what a Superfund site is? Do we not know what a Superfund site is? All right. Layman's terms, Superfund site means that a site is so contaminated that the state has to come in and take it over and create a plan to clean it because the individual or the group that did it initially either aren't around anymore or it's just way too much money. It's not realistic that they're going to ever be able to do anything with it. So the entire creek bed is a Superfund site. New Jersey has the most Superfund sites, if not surprised. This is a news clip that was written last year. The EPA wants to dredge out as much sediments as they can from this Berries Creek and then put a concrete cap. They're going to try to do that again in the Hackensack River that this flows into. They're going to try to do it again in the Passaic River that it flows into. I don't know how I feel about that. But it is a Superfund site and, more or less something should be done with it. I couldn't find the literature that I read in the past, so I didn't take this with a grain of salt. There's no backing to this. But supposedly Berries Creek has the highest mercury content than any other freshwater body in the rest of the world, which is huge. There was another paper that I couldn't locate again, but they said that your risk of getting cancer is over 100% by eating these crabs, which is also huge. They also have, PCBs, chromium, a lot of pesticides going on. And then all the way at the end, we have a duck-billed culvert. So the first time they went in, they put one of these culverts in. They said, we're going to prevent the river from tidally going up, tidally influencing the drainage creek, and it's, end of story. But real quick, this is a tidally influenced site. That's where the water line is. We're going to hit that again, but just to start you thinking, why might that be a problem? So I went out and did a prelim site analysis of what I found. At the beginning of Route 17, we have standing water. It didn't rain for 3 days. A drainage ditch, there shouldn't be standing water. Again, more standing water. You move down a little bit. We have sedimentation. We have sandbars in the middle of this creek. We have more sandbars in the middle of this creek. Colon Creek, they consider it a drainage ditch. Permitting-wise, it's different. We have more standing water in the middle. Move down, more sedimentation. So what is our main concern that we saw? Like what seems to be the problem? I said the word, it starts with an S. Someone just say it. Sedimentation. There we go. But why is this not just an easy fix? Why can't we just go in and take it all out? I said it before, Berries Creek. What's in the sediment? I hear kind of it. Say it loud. What's up?
Mercury.
Yeah, it has a lot of contaminants. And we got some soil samples done, up and down, to see what these contaminants were. And I looked it up, and a lot of these had to do with pesticide company, industry that was being there and just dumping all these contaminants straight into the river. So short-term solution. The borough of East Rutherford, with Beckmeyer Engineering under that, is teaming up with BJ's Wholesale. The New Jersey Department of Transportation is joining this because during rain events, when the drainage ditch floods, Route 17 floods. It's a major commuting highway. Amtrak, because of the railroad that runs over it. Bergen County, with the mosquito control specifically, because we convinced them that the standing water is prime habitat for mosquitoes. The Meadowlands facility, the Meadowlands Commission, and within the Meadowlands Commission is with New Jersey Sports. We're all teaming up, so we're kind of like the Avengers. But instead of fighting crime, we're just kind of all just throwing money. So each one of us are going to throw, we agreed that we're going to, financially take this burden all together. I like the Lord of the Rings better, so we're kind of like the fellowship of throwing money. That project is continuing, so I hope sometime, I'll get gas back and I can tell you how this ended up. So long term, we have the duckbill. during a rain event, the pressure on the drainage side is higher than the other side, so the ductbill will open and allow it to drain out. But because of a high tide event, if you have it building up in the back, the pressure is not as great as the pressure in the front, and the drainage side kind of just forms a bowl and will flood. So we were proposing to put a pump there, so if there is a high tide event with a rain event, it will drain out. My first job out of college was with Brown and Caldwell. Brown and Caldwell is a purely environmental company. The office was in Virginia Beach. My position was an entry-level environmental engineer. I was in the water resource division. I mostly worked with stormwater runoff, but the other side of the office was sanitation, and I showed interest that I liked the sanitation wastewater side, so they threw me some of that work when it was available. East Coast here, that is where Virginia Beach is. It's at the mouth of the Chesapeake Bay. This is called the Tidewater community. This is where we did most of our work. But just to give you guys an idea of how big Virginia Beach is, because I had no idea until they told me to drive to the other side of it. It's pretty big. It's pretty huge. It's hour plus drive to get to one side to the other side. So if they're like, oh, you have to go see the site, get ready for nice drive to be inside the same town the entire time. So there I did stormwater runoff treatment. So say we had no human activity whatsoever, right? We would have the top left picture where we have a forest. Most of the runoff is getting put back into the ground. When we start moving down, we build a house, we put some, a driveway, a sidewalk, whatever. The runoff raises because we have impervious pavement, impervious surface. That water can't infiltrate back down into the ground. You put more houses on, more runoff. You have a city with minimal pervious cover, all that water is going to run off. And what's that water? What's in that water that we care about? That CNP that we talked about before. So here we have a basic stormwater system that you would find in an average urban area. You have a house there, we have an illegal connection. Oh no, that's not illegal. That goes into the street. No, we're good there. It just goes underground. We have a stormwater inlet, right? So in this system that we have right here, the CMP is picked up, carried through the system, and spit out into the lake, which causes eutrophication, right? So we needed to put something in between the system and the environment that would remove the CMP. So we put a sponge, We're going to have the CMP go down and get caught in the sponge. That sponge is called a stormwater management facility, or SWMF, S-W-M-F, SWMF. There's two types that we would design, non-proprietary and proprietary. So the non-proprietary, if you guys take the ecological engineering classes, you'll learn about constructing wetlands, which was a big one that we did. We constructed wet ponds. We would do bioretention basins. Proprietary are man-made structures that take the water in, more or less funnel it or scrub it out, pull the sediments out, and when you pull the sediments out, more or less, you're going to remove some nutrients with it. Here we have one that's removing bottles and other types of trash that would normally get spit out into the environment. We're capturing that litter. All the way on the left and on the bottom, it's a system where we have a non-proprietary and a proprietary. So we have that concrete basin there, but it's found in a dry basin. So when you do the spreadsheet, you could click off both marks. I'm mostly focused on the non-proprietary. So creating a SWMF. We use a combination of AutoCAD and GIS. First you had your site where you wanted to build it, and you had to delineate drainage area. Can someone tell me what delineating a drainage area means? So if we have one point on a map where we delineate the drainage area, we're figuring out all the area around there where that water will flow from. So if you think of the East Coast, we have the Appalachian Mountains. If water falls on one side, it's going to the Atlantic. If water falls on the other side, it's going to the Mississippi. We do that, but very, very small scale. Then we look at ground cover. Again, if it's a forest with a bunch of trees, we're not as worried as if it's just a, example from the last project I did, if it's a BJ's wholesale parking lot. You're going to have more runoff coming off the parking lot than if it's going through a forest. Then soil types. So why would we care about the soil types? If we have a bunch of sand, that's going to react differently than a bunch of clay. So soil type A means that you're going to have the most drainage and lower nutrients running off of it. If we have soil type D, which is like your silts and clays, the water isn't going to be able to infiltrate that as well, and it's going to have higher rates of runoff. So then we put it in the Virginia runoff reduction method spreadsheet, and that's how we found out the volume of the water, the volume of the swim, how much water it has to handle. This is the top of the spreadsheet. This is mostly where you're doing your work. On top you have the soils and different types of surface area, and then on the other side of the spreadsheet, we'll see in a little bit, that's what the stuff we really want. So here's my short little quiz. Oh boy. We have hypothetical 2 plots of land. The first plot of land, equally distributed 5 acres in each one into the land cover. So 5 into forested, 5 into urban, 5 into impervious. But it's all soil A. We have the same exact thing, but in soil D. So on the bottom here, I have my boxes covered up. Which is going to have the highest phosphorus runoff? A spot that is mostly soil A or soil D? I ain't going until someone says it. He gives me an answer.
D.
Say that again?
D.
D, yeah. So it's same exact thing, just the only thing that's different is the soils. Here we have 6.6, and here we have 8. Okay? Here's number 2. So now we have 15 acres in soil D of forested, or 15 acres of soil D over impervious cover over that soil. What are we going to have the higher runoff values for that? Impervious or the forested?
Impervious.
Impervious. There we go. I actually thought, I got kind of excited. I just noticed this when I was going through the presentation one of the times. We actually got a negative value of nutrient runoff when we did it purely on forested. So it kind of gives you insight on how they do the calculation. Forested will take off. Very excited. All right, so here we have another hypothetical. Here it's 5 acres of soil D on managed turf. That's like front lawns, stuff like that. Fields, like baseball field, not football fields, grass football field. And then we have D on impervious, so like parking lot. So you put it in up here, and then whatever value is going to the exact spot, because you can mix up, like this spot is only going to receive this much, you can link them up. On this example, we have the full amount going to a level 2 constructed wetland, and then we get an output. What I really cared about during the initial part was the total volume that I had to size the swim for. This is just an example of the difference between level 1 and level 2. If you put a level 1 in, you're not going to have as much nutrient removal as you would as if you put a level 2 in. Level 2 is for a wetland. Have to, have bends and turns and a lot of different things to try to remove more nutrients. So the end of the involvement with with that project. So what we did was we imported layers from GIS to AutoCAD. We used those layers to size the swim, like we put different volumes in. We got a volume of the let's just say it was a wet pond. We have the volume of the wet pond. We then took those different parts and the different pieces, converted it back to GIS. We created about 22 different swims on 22 different sites. each had that spreadsheet that we just went over. It had a GIS site map. It had a write-up about what we were proposing, how much it would remove, any information that we thought was important. This thing was, 3-inch binder, and there was just a monstrosity of maps. It was huge. And then I left BC. I left Brown Caldwell. I went back home. I was living down in Virginia Beach, personal reasons. I wanted to go back home. And then I, again, worked with Beckmeyer Engineering. This time my position was a staff engineer. Do all the same things as we did before. This was one project that I worked on that I thought was pretty cool. So the wastewater treatment plant there ran on a diesel backup engine. During Hurricane Sandy, we ran out of diesel fuel and had to go to the DPW and start stealing diesel fuel from the trucks, which we got in trouble for a little bit. So to try to prevent that, we converted the engine to run on diesel fuel and natural gas. So natural gas coming in from the line and from the utility pipe from the street is about like 30 psi pressure-wise, and then we had to bump it down to 3. So we had to bump it down before we were able to use it. Again, there's some of that pipe. I've been doing a lot of inspection work. So we have different road projects going on. This is an ADA pad for handicapped residents to be able to use the same walkway that me and you do. There's one over by Eastgate. You guys ever catch that? You guys know what that was for? I used to see them all the time. I have no idea why. The little bumps on there for blind people with sticks, so they could feel it out and then know right before they're crossing the street. People who have to use wheelchairs don't like it so much, but the New Jersey DEP is setting some new regulations, more specifically the NJPDES, setting some more stormwater regulations. So my personal opinion, Virginia had tighter stormwater regulations, and these new ones coming out in New Jersey are more or less looking like the ones that were found down in Virginia. We're also, there we go, getting tighter wastewater regulations. So the wastewater treatment plant that I mentioned with the gas, top left corner, they're getting tighter limits. So we have to figure out ways to get those limits down. Those are all projects that are currently working. This is something I made. This is a road improvement project. So we're going to a road, milling and paving, which you guys may not know what that means. That means that we are taking out the first 2 or 3 inches of the road and making it look good. But certain areas are worse than others, so we might have to go deeper down into the ground to, get the base better, so you have a better product on top. I created a stormwater system with inlets. We had a stormwater pipe down here, so I had to figure out from there going up the different slopes and everything. If you're doing anything like that, Excel is definitely your best friend. So the future, who knows what the future will hold. But my ultimate goal is to become a professional engineer in the state of New Jersey. So the first thing I have to do is take my FE test and become an EIT. I put that off for so long. Do not put that off. I thought, all right, I have too many concussions. I can't take this test now. And then it was like, oh, hold up. This is my last semester in college. I don't want to worry about a big test and have fun. Do not put it off, I'm telling you, because it is harder, so much harder, especially if you're like me, where you didn't have the best grasp of it the first time around. Trying to understand it on your own without the help that you have here is 10 times harder. Just do it now. Don't put it off. Do not put it off. Do not put it off. So I'm trying to expand Beckmeyer Engineering. In New Jersey, we have different licenses for drinking water, sanitary, stormwater, and wastewater. To get those licenses, you have to do a certain amount of time within the field doing that thing, and then you can sit for a test. And once you have those licenses, you can go and work for towns. So there's towns that say, we need a person with this type of license for stormwater. We need someone with this type of license for drinking water. In case one of those systems goes wrong, you have someone on staff that can show up and fix it, knows the town, knows the area. The easiest way for us, I think, to break more into environmental work is for us to get these licenses, and then we could go into the different towns and just say, hey, we're not even here trying to be your municipal engineer, we're just trying to be here to have your New Jersey C2 license. Just some words, you know, you guys gotta stick in there. This is tough. Like, there's many times that I thought, like, this is it, I'm done, like, I'm going home, like, I'm gonna be a whatever, I'm not doing this. Stick in there, it is not easy. You have a special program here. It is a purely environmental engineer program. A lot of the times they'll have civil engineer with a minor in environmental engineering or a concentration in environmental engineering, where you really don't get the basics that you need to fully understand it. Like I said, my friend was like, oh, those processes happen because of oxygen. So hypothetically speaking, if we had an aeration tank and pumped all the oxygen in, but we dumped a bunch of bleach in it, it should work. This is why, well, it's just oxygen, right? No, it's the organisms using that oxygen to convert it. So it is a little bit different type of thinking. You have a lot of opportunity here. You could go up to your teachers and talk to them and know them, and you're just not student number 2,422. Like, you go up to them and be like, hey, I'm interested in this. Can you help me with that? Like, that's pretty cool. Use your resources. Like I just said, use your teachers. Know them. Like, I couldn't tell you how many times I was in Kelsey Green's office with Mrs. Whiten, and I was just like, I'm done. And they're like, no, you're not. Like, you have 1 more month left. Like, come on. Become marketable. Be unique. On paper, when they put the two together, show something that sticks out. Pick up a concentration. I was going to ask you this before, I forgot. I remember you guys were kind of expanding the concentrations that were offered. Is that still happening?
We want to expand the ecological
So the
concentration.
ecological one is the one I did, and I got my first job because I said I had experience with that. And they told me that when I got hired. That is awesome. Pick up a concentration. Take extra classes. They also like that. I was a bio major and I took multiple ecology classes. They like to see that different mixture of thoughts, expand your horizons. Become involved with organization, you know, go Greek. Go join a watershed group. Like, get experience in the field of what you want to do. If there's something that you think that you're interested in, go out and try it when you're still in school. Don't wait till you get your degree and then try to do it when you're trying to handle a bunch of other stuff and then find out you hate it. Try to do it now when you have the time to, you know, it's easier to figure that out. What else? Personal opinion, I think that if you don't have any experience with it, learn GIS and learn AutoCAD. If possible, learn 2D and 3D. Like, I'm not saying like you have to be a pro in it, but if someone says, hey, can you make this box for me on this plan, you're able to make that box on that plan. All right, maybe a little more than that, but that was an oversimplification. Keep a journal. I'm not going to get too much into it, but write down everything. If things don't go your way and people are saying things, and you're able to pull out a journal and you say, actually, this is what happened, and I have the time and the date, and I have these emails attached to it. That will save your butt because it saved my butt. That's all I'm going to say about that. All right, guys, do you have any questions? Again, I'm Glenn Beckmeyer. This is my email address. Send me emails if you have any questions. You know, you have a resume. You're like, how can I make this better? I'll read it. I have a lot of, I have time on my hand. All right, I'll help you guys out as much as other people help me out. Is there any questions? Got like 5 minutes?
Yeah, some questions.
Yeah.